Yes, thank you.
So I'll be talking a little bit about an EU project OntoDESIDE in which our group is involved, and I will be talking a little bit about PatOMat2, but I think actually PatOMat2 is something on which Martin Ledvinka should talk, because he is the actual developer. So I will probably rather present the glue between the overall high-level idea of the OntoDESIDE project and this concrete application, which will hopefully be demoed. And regarding this demo, I also rely on Martin, because he knows, even with the GUI, I've used it a couple of times, but Martin can definitely do that better and smoother to save time. So the idea of this talk is to use some techniques of ontology engineering to support a special application domain, which is circular economy. So among the authors or presenters or whatever in this presentation, I mentioned myself, Martin, and also Ondřej Zamazal, who is actually the PI of VSE in this OntoDESIDE project, and he was also he used to be the lead developer of the previous versions of the technology I'll be talking about. So he's a very important person there. Unfortunately, he couldn't join for some health problems. He was originally meant to give this presentation, but so I'm kind of replacement. As regards the position of the team I'm talking about, it was mentioned on the website that we have a team called SWOE, which is Semantic Web and Ontology Engineering, which is a part of a larger team called Data Science and Explainable AI, DSXAI, which is largely is almost identical, is closely related to the research activities within the whole Department of Information Knowledge Engineering, which is KISI, at the Faculty of Informatics and Statistics at the Prague University of Economics and Business, also known as VSE, here in Prague, in the same Prague as the same entity as where the CTU is based. So about the OntoDESIDE project, probably some of you have already looked at the website. So it's a Horizon Europe project whose aim is to use ontologies as a means of supporting interoperability in the circular economy domain, and this way to help support organizations the transition from involvement in linear economy to circular economy, where any kind of entity, product, material, and so on is reused or recycled as much as possible. And there are specific kinds of value chains and value networks in this economy between different stakeholders. So there's a complex business research area around that. But what we are contributing to is mainly information or computer science and knowledge engineering. The coordinator of the project is Eva Blomqvist from the Linköping University, is also a well-known figure from ontology engineering, especially dealing with ontology patterns. So probably those of you who are active in ontology engineering research already know her name. And the project itself started I think in spring 22, but actually the VSE team only joined the team formally from March 24, but it was even more complicated because we only got the formal approval of our joining the project in June this year, and we received the first funding in September this year, two months ago. So this start was rather complicated, and considering that our first deliverable, which we were supposed to author, was due in mid-August, just 2 months after the project being actually approved. So this is connected to the fact that we really approved the involvement of Martin, who helped us a lot during the summer, and it's largely thanks to him that we were capable of delivering this deliverable, which contained actually more results, but one of the pillars was this PatOMat2 application, which is mentioned in the title of the talk. Just generally, if I survey the activity areas of VSE in the project, it was not just this ontology transformation, but also other things. There is some work going on ontology alignment, which is a topic of Ondřej Zamazal and his PhD student, Jana Voteščinová. In ontology transformation, it's our major task. There are lots of people involved. I didn't list them all. There is also some work which is more business oriented on the circular value chains and problem of contracting in this chain. But actually, it's also quite related to the work of TBSS and ontology engineering people, because there is ongoing development of referential ontologies in OntoUML, so based on UFO distinction by one PhD student. And there is also some work related to developer experience in ontology-based application development. So there is some probably future collaboration with a team from ID Lab Ghent, probably also now people like Ruben Verborg and so on. So they are also part of the project, and we try to collaborate with them. So I find this as really an exciting project, which very well fit our previous experience and results. But still, despite this, let's say, little learning curve we had, we already knew the technology in general, which was supposed to be applied in terms of ontology engineering. Given this tight schedule, it was and is still quite a challenge to deliver what is expected from us. So now going to the actual topic of ontology transformation. The term is not so frequently used openly under this name, but actually there is some ontology transformation quite often as an auxiliary or partial task in various ontology engineering projects. But the research in this field and not even engineering in this field is not much coordinated, and there are some tools and some patterns or other methods of ontology transformation arising here and there under different names, in different contexts, in context of different more global tasks. So a part of our mission in the OntoDESIDE project is also to start a process leading to a consolidation of ontology transformation research and ontology transformation related artifacts for the future service or improvement of ontology engineering practice. So the root of the need, one of the roots of the need for ontology transformation is the fact that given the expressiveness of all as ontology language, I don't have to introduce all, you all are familiar with it. The same or similar content, say ontological content, or content of some situations in the real world, let's say, can be expressed using different constellations of language constructs. And sometimes the problem of expressing some same content using these or other patterns is called the problem of logical structure patterns. And there are some of them already available since the more or less in the advent of the semantic web. So already some W3C patterns for n-ary relationship modeling, or for using classes as values for properties. So this is one part of the picture of the mosaic of different ontology pattern research that's happening. And the problem there is that ontology designers are not often aware of the choices they can make when they have a certain conceptualization, then they can model it, express it in all using different methods, and it's not guaranteed that each method is equally good for a certain kind of use, certain kind of application that would work with it, because some are, let's say, more verbose, some are more parsimonious, some tend to use a more one kind of language construct or the other, like some may be more property chain oriented, some may be more class taxonomy oriented, some might use even data types or individuals in the role of codes in code lists and so on. And if there are ontologies that use a different modeling style in this sense, it's impossible, or it's at least challenging to align such ontologies. If there are multiple ontologies arising, modeling the same domain, it might be tough to align them if they use different kinds of language constructs. And to illustrate that, so a very trivial example, but this example is well, not literally borrowed from a circular economy ontology, but it's inspired at least by what is contained in some circular economy ontologies. Let's have two ontologies, and both of them are modeling the domain or subdomain or of floor panels, of kind of tiles used in buildings. And one ontology has a property material type, or relation material type, which links a panel to its material, and the material type is actually a coded class whose instances are codes for different material types, while the other ontology is just or the fragment is only deals with the floor panels in terms of subclass taxonomy. So so it introduces this different kind of panels. And if we have such ontologies, either physically or either existing or potential, we can ask: does actually the ontology A provide a categorization of panels? It doesn't provide a categorization in terms of subclasses. So if somebody only looks at subclass taxonomy, they cannot see any special categories of panels, right? While the ontology B, does it speak about the material of the panels? Okay, for human observers, it clearly does, but there is no property called material type or no class material type and so on. So how can the problem of ontology style heterogeneity be resolved? In different contexts, there are three different, maybe more, but we are aware of three different techniques and types of methods, and actually tasks in a way. The first one is to devise complex correspondences. When we have two existing ontologies, we can devise correspondences which are not just equivalences or subclasses between named classes, but they deal with some patterns or more complex axioms. The other possibility is that we have one ontology and we transform its shape to a different modeling style. This is kind of central in this talk. And the last possibility, which I do have it on a reserve slide, some backup slides, but I will probably not have time to talk about it, is instead of transforming an ontology from one style to another, and as they can be even more than two styles, it's a kind of pairwise transformation. And the same also ontology alignment is a kind of pairwise alignment. But we can also try to devise some interlingua in which different equivalent or quasi-equivalent structural patterns can be mapped. So we have just one one expression of this, let's say, situation or pattern in this interlingua, and it could be then transformed to different concrete patterns or different modeling style. But I have to skip this because it's beyond the scope of this talk probably. But I will spend a little bit of time on this first bullet, which was ontology alignment, where we can do we can try to find some complex correspondences between concepts. There was one of foundation papers of this was by François Scharf, Andrzej Zamazal from our group, and Dieter Fenzel 10 years ago, where among these different ontology design patterns, there were also these complex patterns with a compound expression on one side of the alignment. And in our case, with floor panels, we can create a correspondence between, for example, between the notion of concrete panel in ontology A and concrete panel in ontology B, where in ontology B it's a named class called concrete panel, and in ontology A it would be a compound expression, which is written here in a simplified way. It's a conjunction of the notion of actually floor. It shouldn't panel, it should be floor panel. There's a mistake. So it is the concept of floor panel, of which we can also say that its material type is concrete. So if we had it in all, there would also be some quantifier for this to be a description logic expression. Whether you probably also know all, you can imagine there could be some existential or maybe universal quantifier as well to make it a property restriction. So now eventually we are moving to ontology transformation, which is a process or task of transforming an ontology or a fragment of an ontology to a different style, to a different structural pattern, but we are trying to preserve its meaning. That's why it's different, for example, from ontology evolution, where while evolving an ontology, it often means that the reality has changed, then the ontology has to be adapted, and the conceptualizing being modeled changes. But in ontology transformation, as we coin this term, in fact, is we transform ontology to its say semantic or ontological equivalent as much as possible. And what is important nowadays, where we are dealing not just with ontologies but also often with bulk knowledge graph, when we transform an ontology, typically we also want to transform the knowledge graph modeled according to this ontology too. And what can be the practical task or coarse-grained task in which ontology transformation can be used? And I will illustrate some of those in the next slides. It can be a partial state in ontology alignment, so the transformation can be embedded as a part of ontology alignment. Then a practical task when visualizing knowledge graphs, ontology transformation can help us say reshape and most typically zoom and unzoom into parts of the knowledge graphs. Then something related to other interests we have in our group is to reduce the search space when mining for rules or patterns over a knowledge graph. When trying to find some frequent hypotheses over a knowledge graph, the search space might be huge if the knowledge graph is modeled according to a complex ontology where all ontological paths are fully expanded with a kind of intermediate entities, let's say. So if we can shrink the ontology to a more compact form, the knowledge graph is shrunk as well, and then data mining can explore a smaller search space. And one more is more, say, ontology-oriented, say, key box-oriented. We can try to discover some implicitly present structures within the ontology and can propose its unfolding, its expansion for its future version. So to go to the examples, first we'll still stay within our ontology alignment, where instead of creating a complex correspondence, we can transform one ontology, here the left-hand side one, the ontology A, to the style of the other ontology, Here it's trivial, it's just a taxonomy. So based on the material type, we create an explicit taxonomy of floor panels, which are made of this material, like glass, metal, or concrete. And a simple ontology alignment tool, which can directly align class to class, like this. Now we have, it's simple lexical matching can detect that there is a concrete panel in both ontologies, so it's quite nature to equivalent. How about this zooming and unzooming? I can demonstrate this on an example of floor panel pedestals, where let's say we have a certain kind of floor panel which is mounted on a pedestal, and this pedestal belongs to some class. Let's say pedestal, there is no duct on this pedestal. That's something we saw in the factory when we visited of our industrial partners in the project, by the way.
Vojta, I'm not sure if it's only me, but I hear it really bad right now.
Yeah,
am I the only one?
There's some tracking, yeah. If it's the mic problem or
I think it's something on the microphone, yes.
Or network problem.
No idea. I can check the mic. Yeah. Let's try it better. But actually, I also see the image frozen. So
yeah. That's right. Maybe if it's a network, but now I can hear you quite okay.
Is it better now for the sound?
Yeah. Now it's okay.
Yeah, let's hope so. And the video is okay, right? Or
yes.
You can see the slides.
Yes, the video is perfect, and the sound is also much better. But it was like the matter of last 1 minute, maybe. So,
yeah. So probably
it was perfect.
Yeah, probably there was some network problem. I don't know. But I'm in my office, so normally the connection should be good. So this was a simple demonstration of what this graph zooming and unzooming could look like. It's just a simple shortcut between we have two individuals, and instead of linking to an intermediate individual which has a pedestal here, we can actually combine or compose this mounting node property with a RDF type, basically, to a single link which can be mounted on a type of, or maybe the naming doesn't really matter at this point, but simply we remove one intermediate node in the graph, this instance graph. Thanks to an ontology transformation, during which this new entity called mounting on a type of, let's say, is invented. So it's a kind of machine learning people would call it predicate invention in inductive logic programming. So here, but we don't do that in terms of the instance data, but we would like to do this at an ontological level. And then the last example, again about this pedestal and nuts. Let's assume that you have a hierarchy of pedestal which contains nutless pedestals and nutted pedestals, and with a bit of NLP we can hopefully find out that there could be some unknown concept called nut, and that perhaps maybe with some human support, there would be a new class called nut appearing, and the nutted pedestal would be something that has a nut as its component. Set aside the description logic technicality. In fact, it's a simplification for a non-technical audience, but so this is just one. So this kind of transformation task deal with proposing possible new additions to this ontological conceptualization, like how about starting to consider nuts as entities in the data model, right? Yeah, so that's I'm close to the end of my talk in a way. So there was a prototype tool in develop, which is called PatOMat2. Why is it PatOMat2? Because there was about 10 years ago, there was a prototype tool which is called PatOMat, which was actually quite similar, but it used a little bit different technological elements, and nowadays the current tool uses Sparkle update, while the previous one used the OPPL tool from Manchester. Doesn't matter. And what is not yet implemented, but there's it's ongoing work. We would like to integrate large language models into the tool, which would propose labels for new entities. Sorry, there was no presentation by Peter Vajdečka. It's just a recycled slide. it's about circular economy, so I also recycling slides to illustrate that, right? So this is a presentation for this is a part of presentation I had together with others 2 years ago at the Prague Ontology Engineering Meetup, where actually Petr Kremen was present, but probably no one from the. I'm not sure if Petr is here actually. Doesn't seem to be the case. So there is no overlap with the audience of Poem, but that's why there is this leftover. Sorry for that. And actually, for the demo, Martin is here. Yeah. So Martin, please, could you? I will stop sharing, and could you please make some brief demo of the tool, because it's more easier for you.
Yep. Yeah. Gladly. I will just share the screen. Oh, not this one. Okay. So PatOMat2 is, maybe I can start here. It's actually, the demo is available online, so you can just go to this URL. I will put it in the post then on our website. And what it does is that it allows you to load an ontology and some transformational patterns, which you can load either from a file or from URL. So, for example, some of the samples are on GitHub. Again, I will put a link in the post, and can actually use some of the prepared examples from Ondra Zamazal. So I will do that, and what that will do is that it will use the pattern. Its source part to, okay, maybe it's not working. Let's try this one. Okay, what's happening? Oh, okay. Now we have something. So what it does is that it takes the source part of the pattern and looks for its instances in the ontology, which is basically this left part. So it says, okay, we have a pattern which is called cat1, and these are the matching instances that or variable matches that it has found in the ontology, and you can see that actually there is a bunch of instances here, and then it allows you to transform the source ontology using the pattern to the target ontology. So both of these, like the searching for the pattern instance as well as the transformation, is done by Sparkle, as Vojta already said. So what we do is that we, maybe I can now show how the patterns are written. So the pattern is described using a simple JSON file, where you have this OP source, which is the source part of the pattern. So you see that these are simplified triple patterns from which a Sparkle query is created. So you can look for some triple patterns as well as using some filters, and based on these, you get these instances of the variables. And then PatOMat will generate Sparkle updates, both delete and insert, again based on some description in or on the description in the JSON file. It actually, the default way it works is that it removes the original instance from the source ontology and replaces it with the new data. So what you can do is either if you want to keep the like the original statements in the ontology, you either replicate them in the target part of the pattern, which is done here. So if you can see that the first 3 lines or the first 3 triple patterns are the same as in the source part. Or what PatOMat allows you to do is to run the transformation without the delete query. So it would just insert the new data. Yep. And if the pattern contains variables for new entities, which for example in this pattern is the G, then it will generate a new instance, a new individual or RDFS resource. And what you can also do is to create a label for this new instance. And to do that, there's basically 2 parts. This first part is what is planned for the LLM experiments, and this NTP part is based on the data in the ontology, and it uses some very basic functions which are implemented in PatOMat. So label extracts the RDFS label from the ontology, nominalize takes the label of the instance if it's available. If not, it extracts the local part of the identifier and makes a noun of it. Yeah, passivize creates a verb and puts it in the passive tense, and this way we are able to generate actually multiple labels for the new entity. So we can see that here in the array you have three ways of generating a label. So you would get three labels, and this again you can see in PatOMat. So these are the transformational Sparkle queries, and this is the new entity. We have just one. This is the G. This identifier is, as I said, generated, and these are the labels which have been generated based on the definition in the pattern file. You are able to select whether this label will be applied or not. You can also, of course, edit them, because since we are just extracting the labels of properties and instances, the new label may not be worded correctly, so you can adjust this. You can also decide whether you want to use the RDFS label property, or you can actually use SCOS. And if you use SCOS, then you can say, okay, this is a pref label. But in SCOS, if you have a concept, then it should have just one pref label. So if I select pref label, then all the other labels will be marked automatically as alt labels. And using this, I can select which instances I can actually apply the transformation on, and then I can just run the transformation again, as I said, either with the delete part, where it would delete the original instance and insert the new one, or apply only the inserts. In case of this particular pattern, it doesn't matter, because the pattern actually ensures that in the target, the original instance is preserved as well. So it doesn't matter if I say delete or not. And you can see that the Sparkle display also tells you, okay, this is the variable B that you can see here. This is the variable G, which is the new entity that you can see here.
May I comment on that, Martin?
Of course.
Just to make a connection between my talk and your demo, what do you see? The pattern is applied here is actually the same pattern that you could see when creating this subclass taxonomy of floor panels based on their material. So there is a property with some value, and it's not exactly the same, but it's very similar, right? So here, when you have a component, and this component has an attribute. So based on this value of this property, there is a new subclass proposed. Yeah, so there's just the same thing.
Yeah, that's it. And yeah, so you can see that we have 12 matches of the pattern in this BPO RDF ontology. If you upload multiple patterns, you can see you can filter them, all this normal basic stuff. As I said, what you can do is either load the ontology from a file or pass an URL from which the ontology should be loaded. The same goes with the patterns. For the patterns, you can actually combine both, so you can use files as well as patterns from URL at this for the same transformation. Yep. There are some restrictions on this because we are using Sparkle. Let's say the expressivity of the transformation is restricted, and also currently PatOMat it uses RDF4J, and it takes the ontology, generates an in-memory RDF4J model of it, and applies and runs the pattern on that. So at this moment, there is no reasoning enabled for this ontology processing. So if you like would need some inferred knowledge or inferred statements from the transformation, you actually don't get them. You would have to use the pattern potentially to get to the reasoning results, although maybe that may not be possible because the language in which the patterns are expressed currently is also quite limited. So you can use triple patterns and filters, and you can actually use in the triple patterns, you can use property paths, so that might help as well. But I imagine that some more complex reasoning tasks will not be possible in the current version. Okay, so that's I think that's it for the demo. Again, the PatOMat is the source code is online. You can either find it on GitHub. Again, I will put the link in the post on our web, or if you go to the demo, there are all sorts of resources, the source code, links to presentations done by Ondra Zamazal, multiple of them, depending on the level of detail that he goes into. There's also Java doc for the backend available. The application is written in Java, or the backend is written in Java. The frontend is written in Vue. And I think that's it for me. If anyone has any questions, either on me regarding PatOMat or on Vojta regarding the context of where PatOMat is used, I'd be happy to answer, or we'd be happy to answer.
Actually, I have one more concluding slide, so if I could perhaps share
sure.
this.
Go ahead.
Final slide. Yeah, my camera will probably remain off. It's probably it died in real time.
Okay.
But sorry. Do I share or not? Not yet.
Yes, you are sharing.
Okay. So there's nothing special on this slide, but just to comment that as you could see, the product can already be tested with 2 transformation patterns. But there is a say semi-structured catalog, even a bit formalized, of about, I think, about 15 other transformation patterns, which is maintained, extended by Katka, my PhD student who's here on the call. And we hope that some more patterns will soon become operational. It could be tested with a tool, you could see. And then in the tool, you could see that there is currently a templates-based approach for generating new names of entities. But in parallel, we are experimenting with using language models, which could give these labels more fluency. And seems to be the case, more or less, even just with some few shot or even zero shot approach. But this is still kind of generic research, even if we sometimes apply it on these circular economy ontologies or settings. But to really demonstrate that it's useful for a circular economy related application will be a big challenge for the next month, especially that the project is currently supposed to finish in May next year. We are asking for an extension, but it's not sure if we get it. So we'll be in a rush, and we'll be pressed to deliver some results, and we'll be happy to stay in touch also with the KBSS group as possible users and experimenters with our technology, and which is actually created in collaboration, as Martin was involved this. Yeah. So that's my side.
Okay, so if anyone has any questions, go ahead. Yeah, go ahead, Miro.
Hi, Vojta. Thanks a lot for a great presentation as well, Martin. It's great that we have you here. I have a question related to how much do you expect this to be like automatic, or are you rather proposing this would be semi-automatic, or rather more like automatic, or what's your goal to have this tool? Like what's the future goal? It should be rather managed by user, or rather used automatically somehow. I see that you are using LLM. You want to use LLM, so
yeah. So my attitude is that there should be a human in the loop, and the point is to ease this say knowledge engineer. Well, currently we are talking about knowledge engineers, right? Ontology engineers. It's I wouldn't really say it might be very tough to get it to the level to be used by domain experts, but maybe by knowledge, or maybe domain experts assisted by a knowledge engineer. And so compared to the version of PatOMat we had 10 years ago, there is more automation. There's a bit more automation already, and we foresee more automation in two respects. Actually, it's a very good question you ask. The first one, which was already mentioned, is the use of a language model to generate the labels. So actually, if the language model were maybe fine-tuned or were fit to the domain, and so I could imagine that there could be something obtained even by choosing the best proposal for language for the label, and the other side, the other phase of this process where automation should be improved is the identification of fragments of the matches of the pattern where the pattern should actually be applied, because it is not the case that every time the pattern structurally fits the ontology fragment, the transformation should really occur, because the pattern, the logical structure of the pattern is quite generic, and one should really to avoid the user scanning a huge list of matches and to choose among them which make sense and which don't. we need more automation even in there, filtering out some structures which are not amenable to transformation, whether it is based on the structure environment of the given pattern, not the pattern itself, but something not which cannot be formalized in such detail, or using some hints also from the naming of the ontology entities. So for the moment, we want to get a good balance between precision and recall in a way, right? We would like to have the pattern itself, say, general enough, not to eliminate too relevant matches in the ontology, but at the same time, there should be some filtering or at least ordering of candidates for transformation, such that the user, the ontology designer, wouldn't have to go through too long a list of match candidates. If this answers your question, so this is the two crucial aspects of automation in here.
Yes, thank you. And maybe one more question, rather, for Martin. I saw it's basically you can take this this configuration and you can generate the queries. I'm curious whether you could use some specific predicates that are related to RDF4J. Like I know that RDF4J has some predicates. So for example, for matching time or some. Is it possible to use it in this JSON as well in the same way, or you can basically enter part of the Sparkle query there inside, right? So
Yeah.
Is it possible to use it as well?
Yeah, I assume it is, because there's actually not much processing of the input pattern. If I simplify it a lot, we just concatenate the triple patterns into a single select query. So it's if you use RDF4J predicates there, I'm pretty sure you can do that. As long as the backend uses RDF4J, which at the moment it does. But on the other hand, we did also discuss with Ondra other possibilities, which again depends on how much reasoning we would want to use. Our initial thought was let's start with Sparkle and RDF4J and see where that gets us. But of course, there are limitations. I've seen problems that I would use a pattern on some ontology. I think I was trying SCOS as well or something like that, and I was not getting any instances, and the problem was that it was not reasoning any hierarchies. So because the reasoning is completely disabled for the RDF4J model that we create. So as soon as you want to switch to some more reasoning, then it's possible that we will, or the development would switch to a different library, maybe Jena or even OL API, and then this RDF4J specific properties will not work anymore.
Can I ask you out of curiosity? What you mentioned, this RDF4J predicates, is it just syntactic sugar which you can replace always with more complex Spark queries, or is it some magic which you can't do in Spark at all?
I believe it's not only syntactic sugar. It's, for example, some function related to data types, to concrete data types, like give me next day of today. Well, maybe this is possible to do, but something that's not only some syntactic sugar. I think we can find some other.
I can imagine it can speed up. It can shorten the query and speed up the process, maybe more efficient. Because things that you have to do with some complex filter, but it's just something we can discuss it later some other time. But it's curious about that.
I would believe that it's not only syntactic sugar, but some of the things in Sparkle are really, really crazy to do. I'm not sure now, like capitalization or making camel case from something else, like, and such a functions could be there. But I was thinking about it because I'm not sure I understand how it works exactly, but you were saying it's in memory. It's working in memory, and for that I believe like much stronger stronger constructs are in Jena API. Like there is like magic properties to match list RDF list, or to split. There are a lot of functions that are, I'm 100% sure, not syntactic sugar, and if this is done in memory, I would prefer probably this Jena API, although RDF4J is better to access remotely the data, and but Jena basically works in the memory. That's how I understand the differences. That the RDF4J API is more to do remote operations, while Jena is doing it in the memory, and Jena is much more expressive than RDF4J.
I don't think it matters in this case, because, as I said, we keep it in memory. We just create a model, so it doesn't matter if it's RDF4J or Jena in this regard. And you can, if you were to use a remote repository, then for Jena you could use Fuseke, and it would be the same, because as long as we generate Sparkle, it's pretty much any Sparkle compatible storage if we were to switch to a remote storage. So it wouldn't really matter. So yeah, maybe in this case, if Jena has more, let's say, more custom extensions to Sparkle, then yeah, maybe it would make sense to switch to Jena. But it's when we
A question also might be as we are working basically with the T-box, and whether we need this kind of tricks for the T-box, where we don't really frequently work with data type values and so on.
Well, I think we don't necessarily have to work with T-box only. I mean, since we are using plain Sparkle, we could probably do basically anything that Sparkle supports, as long as we are able to put it in the JSON structure that we are currently using. So maybe we are not restricted to T-box only. But yeah, as I said, when we started the implementation, we discussed this with Ondra. We were weighing the options and discussing how complex cases we expect to have, and we agreed that we'll start with something rather simple. And for that, RDF4J was for me the easiest solution, because I know it very well, so I was able to put it together quite quickly, which was one of the requirements that we had at the time. So that's why we use RDF4J. Of course, there are also restrictions on the size of the ontology, because since it's not, there's no authentication or anything like that, it would be very easy to just overwhelm the server. So there's restrictions on the size of the ontology that you upload. There are restrictions on the number of active sessions that are connected to the tool, so that it doesn't crash the server. So if we were to go with some much more complex cases, even maybe, as Vojta said, regarding using patterns on the data and not just the T-box, then it would probably make sense to use an external storage and not just keep the loaded data in memory, because that's very limiting the volume of the data that we are able to support.
Yes, definitely. As volume increases, then the RDF4J API is better. Definitely. This is how I understand it. Yeah.
Yeah, but you know, as I said, this is just executing Sparkle. So for that, it actually doesn't really matter if it's RDF4J or Jena.
No, it's
the implementation was easier to do in RDF4J.
Yeah. Jena is only. I'm mentioning Jena only because you can really easily create new predicates, create new something called magic properties, which does not include triples, but tuples that do something. You can really like extend it a lot. The Sparkle itself that you execute at the end.
You can do the same for RDF4J. You can create custom functions in RDF4J. No problem at all with that.
I know there is some mechanism, but I really consider Jena very good in that.
I don't know. I don't have any comparison of that, but I know that you can create custom functions with in RDF4J. I did it actually, and it's not that difficult either.
Yeah. Okay. Not sure if the mechanism is the same because the RDF4J must be done in a way that it works on remote. While Jena is assuming it is in memory somehow, that you have the whole model. This is what's different, that you have whole model all the time. So from that, some expressivity comes from that. You don't have to rely on this remote fetching, or that, you know what I mean. Yeah.
I haven't tried it in Jena. So I don't have any enough data or evidence for that. So, but I guess we can take this offline maybe.
Okay. I can put some reference on what it is possible to do in Jena, like what I said, those magic properties and stuff like that. Okay. Okay. Thank you.